Welcome back, everybody. We're going to do a harder example for volume with the triple integral. We're going to find the volume of the region bounded by two paraboloids, y equals x squared plus z squared, and y equals 16 minus 3x squared minus z squared. So my first parabola, x squared plus z squared equals y, is in red, and it intersects here with our other paraboloid, which starts at 16 and is a paraboloid opening to the left, 16 minus 3x squared minus z squared. So I found the line of intersection. We can see it's not dependent on y. X squared plus, well, other than it's the y's are the same where they intersect. So we set them equal to each other. We solve. We see that z equals plus or minus square root of 8 minus 2x squared. Now, if we look down the barrel of y, we're going to see that this looks like a circle in the xz plane. So let's take a look at that to find our other limits of integration. From along the xz plane, we've got this z equals square root of 8 minus 2x squared. I can graph that in the xz plane. So we can go along z first, from negative the lower square root to the upper square root. Then we can iterate along x. We see that when we plug in z equals 0, which I do right here, we get 2x squared equals 8. X equals plus or minus 2 gives us these limits right here. So we've got our limits. Y is between x squared plus z squared. That's my lower boundary. The upper boundary is the 16 minus 3x squared minus z squared. Z will be between the two square roots, and x is between negative 2 to 2. I set up the integral here. The function is 1 because we're finding the volume of that region. So we don't need a function to go with it. And I've started doing this. I hope you like it. I hope it helps you. I hope you consider doing it yourself. Putting in the corner of your little integrand symbol what variable is being integrated there. It doesn't take up a lot of space. It helps you track what's going on. We're actually going to do this, though. Let's find it. So that's the function we had. We integrate with respect to y first. We just get yb minus ya. When we combine that together, 16 minus 4x squared minus 2z squared. I factor out a square root of 2 here, and I get a 4 minus x squared. And I can see this is going to have a 4 minus x squared too. I decided to use a variable, the smiley face. I didn't even put a circle around it, just smiley face. So when I integrate with respect to z, this part doesn't have a z, so I just have it here times z. This is, we factor out a 4, it's 4 times 4 minus x squared. This is 4 smiley faces times z. And then we've got 2/3 z cubed. And again, to save myself writing, smiley faces, square root of 2, smiley face, and negative square root of 2, smiley face. We plug them in. When we're doing the square root of 2, the square root of 2 cubed is 2 root 2. So I just did it off to the side real quick. So I got 4 smiley face times z, these things. So I'm going to have, for the first one, just the square root of 2, and then the square root of smiley face minus negative square root of 2 smiley face. We can see some stuff combines here. This will turn into a plus. We'll have 2 of these. When we do the 2/3 one, we've got, I put this at the end because it's the square root of 2 cubed. We've got smiley face to the 3 halves minus negative smiley face to the 3 halves. This ends up giving us negative 2 to 2. This gave us 2 root 2 smiley faces. So 2 root 2 times 4 is 8 root 2. And we've got a smiley face out here. Smiley face times square root of smiley face is smiley face to the 3 halves. Then on the other one, we've got these, this turns into a plus, and we've got two of those. So 2 times 2 root 2 is 4 root 2, times 2/3 is 8 over 3 root 2. And the smiley faces is 2 3/2 again. And so combine it all into one little thing, and I got rid of the smiley face now because that's what we're integrating x. You get a common denominator. This ends up being 24 over 3 root 2. So 24 minus 8 is 16. 16 over 3 root 2. Then we're going from -2 to 2 of 4 minus x squared to the 3/2. The x, again, we got another formula. This is a squared minus u squared to the 3/2. This is what you get. Kind of pain in the butt, huh? That's a pretty nasty formula. So how does this compare here? A has got to equal 2, and u has got to equal x. So that's what we got there. So let's work it out. Got my 16 over 3 root 2 on the outside. Conveniently, when we do the square, 2 squared and -2 squared is 4. So this turns to 0 each time. This entire piece is going to get knocked out. So we just have 6 sine inverse of 1, which was 2 over 2, and then minus 6 sine inverse of -1, which was -2 over 2. And so we got our 16 over 3 root 2 on the outside. Sine inverse of 1 and sine inverse of -1 is pi over 2 and negative pi over 2, respectively. This ends up being 32 pi times the square root of 2. Nasty, right? This was a nasty problem, 2-page problem. But did we expect anything any different when we saw the paraboloid? No, we knew it was going to be nasty. One more section. Peace.